So today we are starting 7.6 properties of logarithms. Okay, so properties of logs. This will be page 145 if you're going to keep up with your notebook for the notebook test grade. Just FYI. So our main understanding is to understand that logs and exponents have corresponding properties. Okay, that's because the log function and the exponential functions are inverses of each other. You remember that from last week? They're inverses of each other, so of course they're going to have similar properties. Okay. First, we're going to talk about the definition of a logarithm. Okay, the logarithm. If I have log base bm, it's saying the exponent to which b must be raised to get m. That's literally what it's asking you. So how that works, we have three types of logs. We have logarithm, just your basic log function with any base greater than 0 but not equal to 1. And then we have my pen not working. Huh. Uh-oh. My pen stopped working. Oh no. I don't think so. It's never died before. Disconnected. Oh, there we go. All right, so here we go. Sorry. So we have our log. That means your b can be anything as long as it's greater than 0 but not equal to 1. And your x has to be positive. Okay. X has to be greater than 0. That's what the x greater than 0 means, is it's positive. So it's saying that I can take this and write it as an exponential. So we have log base b x equals y can become x equals b to the y, because that's what log is asking you. Log is saying, what power makes this true? Like what is it asking? What power would make this true? Natural log, the key thing with natural log is that natural log, it's log base e. Okay, but we don't write log base e, we write ln. It is not in, is not in, it's ln. Okay, it's a lowercase l and a lowercase n. I have no clue why they made it that instead of nl, don't know. But if you get bored, I'm sure you can research why. Okay, so we have log base e is natural log. And when you're writing that, because its base is e, therefore it's going to be x equals e to the y. All right, common log, that's when we have log base 10. But we don't write log base 10. It's a little redundant. It's called the common log. It's automatically there as a 10. So we have log base 10. And so therefore it's b, when you're writing it, would be 10 to the y. Okay, the best way to do this is just kind of dive in with the examples, because it's looking at it, it's like, yeah, I get it. Not really. The other thing I want to strongly suggest is if you can't remember these rules for your note card for your test, should this be something you write on your note card? Yes. If you can't memorize this, then this is something that you should put on your note card for your test. Got it? All right, so let's see how they apply. So I'm going to tell you right now, it's always alphabetical order. It's your b, your x, and your y. Alphabetical order. B, X, Y. Okay, and when we're writing this, we're saying x equals b to the y power. So what do we have here? Our x is 16, our b is 4, and our y is 2. Is that a true statement? Does 16 equal 4 squared? Yes. Okay, again, it's b, x, y. And so when we write this, our x is 7, our b is b, and our y is 5. So that written as an exponential is 7 equals b to the 5. Okay. Natural log runs a little different. When you see natural log, your b equals e. So you have your b, your x, and your y. So this is saying c equals e to the 3rd power. You can move your desk if you need to. And that's how you go from a log to an exponential. Do you see the pattern? There's Napkins and paper towels on the shelf. Yes. Okay, questions, comments, concerns?
So the N is the B, not the B.
So this one, because if B is not visible, is B equals E. So its B is not visible. Okay, all right, any other questions, comments, concerns? Are we good? All right, so now we're gonna go vice versa, okay? So going vice versa, we're gonna go from exponential to log. So now we have exponent and we're gonna write it as a logarithmic. So for log, it's log base B x equals y. Okay, and the way I remember this one is say by to your x, by to your x. Because it's not alphabetical, so you had to come up with this. Okay. Huh? All right, so say by to your x. That's what, so when I'm writing this, my log, my b is 2, my x is 1/8, and it equals -3. Do we see it? All right, again, say by to your x. So log base is 10. X is 1 equals 0. Now, log base 10 is redundant, so it's just log of 1 equals 0. And this is just saying 10 to the 0 power is 1, which is a true statement, because anything to the 0 power is 1. All right, again, by to your x, by x. So that gives us log base E 12 equals A. Now, when you have log base E, what do we say that meant? ln, it means natural log of 12 equals A. And that's the correct. What are your questions about going from exponential to log? Now, these skills are going to come in handy for when we start solving them, which is why we have to learn these skills before we start solving. So this isn't the problem. The problem is once we start solving. Does that make sense? Right now, we're building our skills up to solving. All right, questions, because if you can't do this, then you're going to struggle when it comes to solving. Good? Yes. Which way? Usually when you're using that, you're going to have like terms. And so all your like terms are going to need to be in the natural log in order to combine. So the correct and grammatically correct way of writing is ln. All right, so now the next skill that we're going to have for solving is simplifying log expressions, okay? So when we're simplifying our log expressions, we have 5 main properties, okay? Our first 2 properties are our inverse properties. So these are our inverse properties. Property number 1, it's saying that if you have a log expression raised to the same base as the base of the log, they're going to quote unquote cancel each other out, and what you're left with is your answer. Okay, this also applies to natural log. If you have e to the natural log of m, they're going to cancel each other out and you're just going to be left with m, because they again are inverses of each other. Okay, property number 2, if you have a log of a number with the same base as the log base, they cancel each other out and you're just left with the number, that power. That works also with natural log. If you have natural log of e to the m, it's going to cancel each other out and you're just going to be left with m. Now, when it's so many letters jumbled together, the best way to see this in effect is if you have numbers. Does that make sense? All right, so an example of property number 1 is right here. We have 5 to the log 5 of 18. The base of my exponent and the base of my log are the same, so they cancel each other out, and I'm only left with 18. That's how property number 1 works.
Wait, so is that 5 to the power of log 5?
Mhm. All right, here we have log base 3 of 3x to the of 3x minus 2 to x minus 2. The base of my log is the same as the base of my exponent. They're going to cancel each other out, which is what property number 2 is telling you. And all I'm left with is x minus 2. Okay. Property number 2 in effect again, but this time with natural log. That's a weird looking 2. I have a natural log of an e, which means that they're inverses, so they cancel each other out, and I'm left with just 3 to the t. Property number 1 example with natural log. I have e raised to the natural log of t squared. Again, these are inverses of each other, so they're going to cancel each other out, and I'm left with t squared. Just like if you were adding or subtracting the number, it's going to cancel each other out, right? Or multiplication cancels out division. Inverse operations, inverse functions are going to cancel each other out. How do you feel about inverse properties? Questions, comments, concerns? Good. All right. Property number 3. This is our product property. Okay. Do we all remember the product rule from exponents? When you're multiplying 2 exponents, if they have the same base, then you're adding their powers. Y'all remember that?
Yeah.
All right. Very similar rule for log. If you are multiplying 2 numbers within a log, you can separate them into an addition problem and vice versa. If you're adding two logs together of the same base, you can condense them down to multiplication. So it's the same, very similar rule. All right. So here, the reason why you want to expand is because you want to separate your variable and your non-variable, your coefficient, right? So if I wanted to separate 5 and x, I can expand them into their own logs. So it becomes log base 4 of 5 plus log base 4 of x. That's what it means to expand. I separated unlike terms. Make sense? Okay. To condense down to 1 log, that would be me combining like terms typically. So if I want to combine like terms, I'm going to condense them down to 1 log. So this is an addition of the same base, which means that I can now turn it into a multiplication problem. So 6 times 10. And what is 6 times 10? So my condensed log would be log base 2 of 60. What are your questions about condensing with product, huh? Yes, you simplify all the way. A good question was asked, if I can multiply, do I multiply? Yes, you simplify within the parentheses. How do we feel about the product property? Awesome. Now we're on to what's called our quotient property. Okay, quotient property. Previously with exponents, you learned that if you're dividing 2 exponents, that means you're doing what with their powers? Subtracting their powers. Remember that? Same thing with 2 logs. If you're dividing within a log, you can expand it to 2 separate subtraction problems. Okay, on your notes, could you cross out LOG and put LN? I thought I had updated your notes before I printed them, but apparently the update did not save. So it should be natural log of 6 divided by X and natural log of 50 minus natural log of 25. The reason why I put natural log is to show you that these rules apply to natural log because it's still a log. Okay, so you're crossing out LOG and you're putting LN. Got it? All right, so let's proceed. So if I wanted to separate these two unlike terms, I can go from a division situation to a subtraction. Division goes to subtraction. Division goes to subtraction, right? So it becomes natural log of 6 minus natural log of X. Yes, example 7. All right, example 8, I want to combine like terms. So I want to go from subtraction to what? Division, to combine like terms. So we have natural log of 50 divided by 25. And what is 50 divided by 25? 2. So the natural log of 2 is our final answer. Okay, how do we feel about property number 4? Quotient property. All right, property number 5 is our power property. It's how we deal with the power. Now, back in Algebra 1, you learned that if you have a power raised to another power, that just means you're multiplying those two powers, right? Yeah, remember that? All right, when it comes to log and exponentials, log function, log properties, the power rule is that your power can become a coefficient. It can become a factor. So your power can be a factor / coefficient. If you're trying to separate. So for example, on example 9, we have log of X to the 3rd. I want to separate my variable and my number, right? So that means I can take my power and turn it into a coefficient. So it becomes 3 log X. This will be useful when solving because now this allows me to move and isolate my variable. Okay, now on the other hand, what if I'm trying to simplify or combine like terms? I can now take my variable, my factor, and turn it into a power. So this becomes log base 2, 3 squared. And what is 3 squared? 9. So it becomes log base 2 of 9. What are your questions about the power property? Property number 5. None? All right, cool. All right, let's apply some here. So we're going to talk about consolidating. I thought I had included expanding examples, but apparently I did not. So we're going to look at those when we get to the practice part, okay? So when we are trying to go from from multiple logs down to 1 log, we're going to go through our properties. The property you should always check first is number 5. So check for property number 5. Are there any factors that can become powers? Yes, 3 can become the power of Q and 6 can become the power of V. Do we see that? So that gives me log base B Q to the 3rd plus log base B V to the 6th. Okay, after this, you're going to ask yourself, can I use property number 3 or property number 4 to consolidate? Property number 3, and why is it number 3? They have the same base and you're doing what? Adding, right? If there's addition, that means it leads to multiplication, right? So we have log base B and it's going to be of q to the third times v to the 6. So now I condensed it down to 1 log. Using the same logic, I would like for you to try example number 2 at your table. All right, so first thing, you should always check property number 5. Can we apply property number 5? Yes, so we could take our factors and turn them into powers. So we have log x to the 4 minus log x plus 2 to the 6. Because the bases are the same, and this is subtraction, I know that I'm using property number 4, the quotient property, right? So this becomes log of x to the 4th divided by x plus 2 to the 6. And that is your 1 log. How do we do on the 1 log? Yes. Okay. All right. So what we're going to do, change of base. Now, change of base is a very interesting formula, but the only calculator that you don't have to worry about change of base on is literally the TI Inspire. That's because TI decided to make an even smarter calculator to make students just a little bit more lazy, okay? And it automatically allows you to put in the base. However, you're not going to always have an Inspire, and actually next year I think Inspires may not even be utilized here. All right, so we have here log base b to the m. And so with log base b to the m, change of base formula is saying that you're going to take the log of the number and divide it by the log of the base. So you're taking the log of the number and dividing it by the log of the base to find its answer. And that's how the formula works. So for example, let's just pretend we don't have access to a TI Inspire, right? So to find this answer, to evaluate log base 3 of 91, I would have to find the log of 91 and divide it by the log of 3. Okay, and you can do this with any standard calculator. So even when you take your phone and turn it sideways, you can calculate this. So on a standard calculator, I'm going to open, where'd my calculator go? I guess I closed it. Here it is. So I'm going to do 91. I want the log of 91 divided by the log of 3. and it says, oh, here's your answer. So approximately 4.11. So that gives me 4.11. 4.11 means that approximately 4. Rewrite this. Erase, erase, erase. This means that 3 to approximately 4.11 is approximately 91. So if I raise 3 to the 4.11 power, the answer would be around 91. Huh? Yep. Well, evaluate log. We're not solving anything because there's no equal sign. It's just evaluating. But that's what a log is asking you. To what power makes this? So here we have evaluate log 2 of 281. So you're asking yourself 2 to what power is roughly 81, right? So to calculate that, I'm looking for log of 81 divided by log of 2. So I'm going to grab a standard calculator. And this time I'm putting in 81, take the log, divided by 2, take the log, hit enter, and it says 6.34. So approximately 6.34. So this is telling me that approximately 2 to the 6.34 power is roughly 81. So when would something like this come in handy is if you remember exponent is where you're repeatedly multiplying, right? So if I'm trying to figure out how many times would I have to multiply or compound interest or quickly assess something in order to get $81 or to have 81 supplies of something, I would have to do it about 6 1/3 of a time in order to have what I'm looking for. Okay. All right, so on the practice, we have your expressions for condensing. So 1 and 2, you're condensing. For 3, 4, and 5, you're actually expanding. So remembering and applying the properties. On 5, this is your hint for 5. It's a challenge one. So you have log base B. Just remember that the square root of something means that you are to the half power. Okay. And so on expansion, you're going the other way. 5. Did I say 4? Oh, 5. So on 5, that's what that would be. And then change of base. This is just another way of asking for the change of base, but just calculating log base 7 of 40, log base 9 of 70, log base of 81 of 3. Okay, so those are your practice. Your practice problems will be very helpful to complete and go through, because if you can do the practice, then you should do really well on the classwork. Okay, practices again aren't checked really for completion until I grade your notebook.
What page is this?
It's just practice.
So